The biggest thing to remember is you're not allowed to distribute the squared symbol. I can't say that this is x squared and this is 36. I need to remember it's x minus 6 times x minus 6. So if I'm going to set up the box, I put my binomial across the top and down the side. Right? People who were here or people who weren't here, you can kind of catch on. So then to find the area, you multiply x times x to get x squared. Negative 6 times x to get negative 6x. So your first step is multiply. This is page 210. Everyone find where we were? So this is x squared minus 6x, another minus 6x. Negative 6 times negative 6 is how much? Positive 36. So the first step is to multiply, and the second step is to look for any like terms and combine your like terms with adding. So my final answer is a trinomial, x squared. See how I have two of these that are both negative 6x's? So I have negative 12x and then plus 36. So my final answer, x squared minus 12x plus 36. Now you try number 6, setting up the box or foil, however you like to do it. And then there's 2 on the back that we're going to convert vertex into standard form and then learn a little bit about standard form. We're kind of on our last set of notes today. We're going to do some review and practice the rest of the week. Test on Friday. So I'm going to write mine down and you can check. This is kind of one more skill that I think a lot of you are strong at from Algebra 1. So maybe after you've tried it on your own, you can look up and see if we have the same thing. Good on that? Feeling that we kind of remember it from last time? Yeah. Let me check. So can I turn to the next page? So on the next page, the only difference is this is now a function in vertex form. And you need to do your box method first, and then in this case, then distribute the 3. And in this one, you're going to do your box method first and then subtract the 8. So I'd like to see if you could try 7 and 8 on your own. We did similar in example 3 and 4 on the front page. So if you forget how to do 7 and 8 as a warm-up, turn back to number 3 and 4, and I'll put the answer to just worry about this guy first. We're ignoring the 3 for now. You're just going to do the x plus 5 times x plus 5. Same thing on number 8. You're going to ignore the negative 8, and you're just going to worry about the x plus 4, x plus 4. So do that step first. Then on this one, you're going to multiply 3 times everything in your answer. On this one, you're only going to subtract 8 from the constant term. But at least if you practice the first step, this step is right. Put all 3 of these terms in parentheses, and you're going to distribute the 3 to all 3 of the terms. Yeah, great. Okay. Why don't you think you're not doing it? Oh, good. Make sure you write your x there, so you don't have to use that term. Okay, so we should get x squared, 5x, 5x. Make sure you don't put 10 here. Remember, you're multiplying 5 times 5 is 25. So the whole first step is just what we did on the front page. Now I'm going to worry about this 3 sitting in front of everything and distribute the 3 to the entire function. So there's your 3x squared, there's your 30x, and there's your 75. This equation, if you graph it, will come out the same as this equation. This is way easier to graph, right? Because this is vertex form. What's my transformation rules on this function? What's the x plus 5 do? Left by 5. And what does the 3 do? It's really steep and tall. Looking at this function, I can't really tell where I'm supposed to start my graph. I can tell from the 3 that I'm really steep and tall. And we're going to learn that this 75 tells us a piece of information. But they're very different from each other. So be grateful when it's in vertex form, and we're going to learn standard form today, how to do standard form. So what is this? 16. X squared plus 8x plus 16. But then I'm subtracting off 8. So my final equation would be, what, 8x plus 8. So like one of the questions on the quiz Wednesday or the test Friday to convert from vertex to standard form or multiply the binomials. So the new stuff, the last stuff of the unit that I wanted to show you today, then we're going to spend Tuesday practicing, forget if we're doing a group problem, but we're doing a quiz review sheet. Wednesday we're doing a quiz and some more practice. Thursday we're doing a team test. So you're going to get lots of practice on it this week. I'm looking for the last resource page. What are we on? 210, yeah. Resource page 210. And then every single resource page should be filled in so that you can get your 20 out of 20 when I'm checking them this week. So if you don't have one of the resource pages, you could even flip through that right now and maybe take a picture. So why don't you take so this equation, ax squared plus bx plus c, I want you to just compare it. So you don't have to write this down, but I'm going to put right above it ax minus h squared plus k. Because we've already learned vertex form. So I just want to compare. This is standard form. This is what we're doing today. This is vertex form. This is the other form that we've already learned. Do you see how they're both quadratics? Because they both have an x squared term. This side, just question? Can you wait till we're done the notes? You really have to go now? Okay. So can you, I lost my spot here. All right. So the A actually has the same job, but the H and the K are different from B and C. So this is called vertex form because this is your left, right, up, down. This is not left, right, and this is not up, down. So the A has the same job. Do you remember what A's job was in the past? It had two jobs. First of all, it's a stretch, right? I'm going to write stretch question mark. And remember when A was positive, it was concave up. And when A was negative, the graph was concave down. So that tells you if the graph is going to open up or if the graph is going to open down. There, it's a little bit bigger for you that way. Okay, so B. B is going to tell you where the vertex is using this equation. So I want you to write down negative B over 2A. We're going to learn what that means, but that's the x value of the vertex. Yeah. So A tells you the stretch and if it's concave up or down, and B is this equation. Negative B divided by 2A is the x value of your vertex. All right, I'm kind of writing. I don't have enough room. So that all goes with A. This is a really important formula you're going to memorize, negative B over 2A. And then C is actually your y-intercept. because when you plug in 0, remember find a y-intercept, you could plug in 0 for x, right? Because on this is x is always 0, right? So if I plug in 0 for x, this goes away, and I'm just left with c, the y-intercept. So those are the 3 pieces of the puzzle. So I always tell students to do them in order of their A, B, C's. So I kind of write my work down here in order of A, B, C's. So example 1, x squared minus 6x plus 4. So we have to learn a new strategy to graph this because it's not left or right, up or down. It's not written in vertex form. Your first step is to identify what is A, 1 in this case, what is B, -6, and what is C, +4. So I always tell students, write down the coefficients first, 1, -6, and 4, so that you don't lose track of what A, B, and C are in this problem. Now, what happens if I write my equation backwards? What value is A in this equation? A always goes with which variable? The squared. So this is not written in standard form, and before you start the problem, you need to rearrange it so your x squared term comes first. So A is always connected to the x squared, no matter where it's written in the equation. So wherever the x squared is, that's your A value. All right, is it concave up or down? How can I tell? Positive, so it's concave up. So it's going to look like this because the A value is positive. Is it going to be a vertical stretch? Compression means less steep, or is it going to be the same as the parent graph? And how do you know? Same as the parent graph. How do you know? A is just 1, right? It's not a 2x squared. It's not a half x squared. All right, so next, this equation of the line of symmetry is the x value of your vertex. So this is where we're going to do the equation -b divided by 2a. What does -6 turn into? What's a double negative? So if my b value is -6 and I'm doing -b, now I have +6 in the numerator. And what's 2 times my a value? So 2 times 1 is 2, and 6 divided by 2 is 3. So the equation of my axis of symmetry is that x is equal to 3. All right, so here's the part I didn't list up top. How do I figure out the coordinate of my vertex? If I know that the x value is 3, how do I solve something for the y value? What can I do with an x value? I know the x value is 3. How can I use an equation to find the y value? This is my equation. Y equals x squared minus 6x plus 4. I know what x is. How do I find y? Plug 3 into the equation for all the x's and figure out what the y value is. So let's write that out. Y is equal to 3 squared, because I have x squared up here, minus 6 times 3, and then plus 4. So can you do order of operations? What would I do first for order of operations? 3 squared is how much? 9. What would I do next? Yep, what is 6 times 3? 18. 9 minus 18 and then plus 4. I'm doing a bunch of mental math to find the vertex. What's 9 minus 18? -9 and then plus 4. So what's -9 plus 4? My final answer? That was a lot of work, but my y value is -5. So do you see how much easier now vertex form is? I had to do all of this just to figure out my vertex goes right 3 and down 5. So now put your vertex right 3 and down 5. And we already said this is the parent function. Do you remember the points for the parent function? Over 1 and up 1 from the vertex, over 2 and up 4, and over 3 and up 9, right? 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like I intersect right here at 4 on the y-axis. So I'll give you a second to graph your parabola. If you forgot these key points, 1, 1, 2, 4, and 3, 9 should ring a bell from graphing parabolas. Oh, I forgot. What is the coordinate of the y-intercept? What's the c value in the equation? 4, right? 0, 4. Did I hit 0, 4 when I just graphed? So you can actually use your graph and your y-intercept just to confirm that you did the problem correctly. Because this value, this c value here, should be the y-intercept on your graph. Because when you plug in 0 for x, you get 4 for y. So that was it. This is the hardest kind of part of the unit because everything leading up to this hasn't involved this much algebra with graphing. It only involved transformation rules. So we're going to spend a whole day practicing this standard form. Let's do another one together. So my first step is I write down what is A, what is B, and what is C in this equation. What do you think A is this time? Very good. A is -1. What is B? The coefficient 4. And what is C? -5. So this is our resource page. So I'm going to go through these with you, and then we'll do some practice, and I can walk around. Is this going to be concave up or down? Down this time, because the A value is negative. Is it going to be a vertical stretch or shrink, or same as the parent graph? Parent graph again, right? Because it's still a 1x squared. It's not 2x squared. It's not half as much. It's the same as the parent function, just flipped upside down. Okay, so equation of the line of symmetry. This is the only formula that you need to memorize besides kind of transformation rules, parent functions. So -b divided by 2a. What is -b for this equation? Okay, so -4 divided by, and then what's 2 times a in this equation? -2. What is -4 divided by -2? So x is equal to +2. Now I need to figure out my vertex, 2 comma something. So I'm going to plug 2 back into this original equation up here. So let me write it out. I would have -2 squared plus 4 times 2 and then -5. This is a little bit tricky because of the negative sign. What do you do first with order of operations? Remember we said this is really like a -1 right here. So this at this step is really -1 times 2. So you actually do the 2 squared part first, then multiply by -1. So you still get -4 at that part. So what's -4 plus 8 minus 5 equal to? -4 plus 8 minus 5. Or -9 plus 8 is what? -1? Should be -1. Because you have a total of -9 and you have a positive 8 right here. So that should equal -1 as your vertex. So we are going to go to +2, comma, -1. And we're going to do our parent function moves just upside down. So over 1, down 1, 2, 4, 3, 9 should all fit. So 1, 1, 1, 2, 3, 2, 4, and 3, comma 9 would put me at what, -10? Should be a smooth curve. You connect the dots, you put your arrows. What's the name of this graph? It's a quadratic, so its graph is called, begins with a P. Parabola. Does the y-intercept match what you think it should be? What should the y-intercept be from our equation? Remember our equation, this C value should have been our y-intercept. I always save that last. I'm like, okay, if this -5, did I hit -5? Yes, I did. If not, I must have done something wrong. Either the wrong concavity or the wrong vertex. So that's it. So if you do this a few more times, maybe you'll figure out how to do the vertex. So let's skip to page. We'll do maybe one more practice together, and then after lunch, we could do some practice. I think it's on page 211. Today's the last kind of day of like, oh, let's grind out some practice so that tomorrow we can do some quiz review kind of on our own. But this is, let's do one more together before lunch. And then after lunch, when you come back, you can work on some practice on your own. Did everybody find their way to 211? This is a good one to do together because the A value I notice is now a 2. Do you remember how that changes your moves over here? Remember we doubled the height of our parabola? So 318, 28, and 1, 2. We're going to need that set of moves. Did everyone find 211? So our first step, why don't you write down the first step yourself? What is A, what is B, and what is C? Let's call it the ABCs. So A is 2, B is -4, and C is -8. So I didn't write the steps for you this time. So literally you do your ABCs. What does A tell me about? What does that 2 tell me? It tells me 2 things. It's concave up. So in my head, I know my graph is going to be like that. What else does the 2 tell me? I just talked about it over here, right? It's stretching it. So you're either going to write like stretch or you could write parent graph. All right, now I do my B, my ABCs. So what is the B value? What do I do with that? I do my formula, -b over 2a. So now I'm actually going to calculate where the vertex is. So what is -b? Originally, b is negative already. So what's the opposite of that? So +4 over, yep, 4. And what is 4 divided by 4? Anything divided by itself is 1. How do I find the y value? Plug it in. So why don't you try to plug it in and see what you'd get? So when I plug it in, I'm doing 2 times 1 squared minus 4 times 1 minus 8. Don't be tempted to do 2 squared. The 1 is getting squared, then you're multiplying by the 2. So you get 2 at this step, minus 4 minus 8. What is 2 minus 4 minus 8? What is it? This is a total of -12, and this is a +2. So I'd say it's -10. Am I doing it different from you? 2 minus 4 would be what? -2 minus 8 would be -10. So I'm going to put my dot at 1, -10, way down here. And then I'm going to do these moves. So actually, I think all of these will be able to fit. Over 1 up 2, over 2 up 8, and over 3 up 18 to show how steep it is. Over 1 up 2, over 2 up 8. Remember, you've got that symmetry. And then over 3, if I'm at -10, 18 would put me at +8, right? Actually doesn't look that steep, but. And then double check, did your y-intercept land where it should have landed? Yep, it should have been at -8, and our y-intercept should have been -8. So it did land where it was supposed to be. So you still have a few minutes. I'd like you to try number 2 before lunch, and that way we can check it when we come back. So see if you can write your ABCs of number 2. And maybe I've already done before lunch. So while the couple people are coming back from the restroom, let's see how you did on this one. And then I want you guys to work on the back, kind of in partners, or let's see, A is -1, B is -2, C is 6. So if I do the ABCs, this is concave down, right? It's going to go like this. It is the parent graph because it's a 1 in front of the x squared. -b over 2a, let's see, +2 divided by -2 is -1 comma. Let's see, when I plug in the -1, I still get a -1. Plus 2 plus 6 is 7. So I've checked a lot of yours. -1 comma 7 is the vertex. Parent function opening down. Over 2 down 1, 2, 3, 4. Right? And over 3 down 7, 9 would be at -2. Does that look like? Sure. And it looks like our y-intercept double checks that it was at 0, 6. The 6 from here and the 6 on my graph match. So try the back page. I'll walk around. You try the back page with partners or whoever you want to work with. And maybe we'll have time to do a quick category game at the end. We're going to finish this back page. All right, so on the back of that 211. Back of 211. We'll see how we do on it. So back of 211. I'll leave that up. And I can come around and help. Practice that formula. -b over 2a. -b over 2a. A couple of them are practicing on foil. And then if I check the back, you can start on one of those couple homework assignments. We technically have learned every single thing now from this unit. We're on a week's worth of practice and review. Who needs some help? We're jumping on the back. I'm going to wait to put this in the video. It won't seem as hard. But when I write you guys did this step right, A, B, C's. And most of you said that it's concave up and it's less steep. And then we have to do -b divided by 2a, so -1, and then 2 times 1/2 is 1. So I think most of you got to this step. You figured out that x was -1. The algebra is a little bit hard maybe because there's a fraction. So we have to do 1/2, and then I'm plugging in -1 and squaring it. And then I'm plugging in -1, and then I have to subtract off 4. Because you're squaring the -1, that becomes a +1 here times 1/2. That just becomes a 1/2. So I have 1/2, and I'm subtracting off 5. So what's 1/2 minus 5, right? Because I'm subtracting 1 and I'm subtracting a -4. So you're at -4.5. So -1, and then I know that it's kind of yucky to graph a vertex at -1, -4.5, but there's a reason that it came out that way. It's kind of hard to see where it is up here. What is your y-intercept? So this one's kind of meant to help you. Your y-intercept is at -4. So that means, see how that's going up from your vertex over 1 1/2. Now you can do the rest of these times 1/2. So this would be 2 and this would be 4 1/2. So even though it came out as -4 1/2, it ends up intersecting your y-intercept at -4, which is where you wanted it to intersect. So I'd be at -4, and then from the vertex, let's see, if I'm at -4 1/2, I would be at -2 1/2, right? So I'd go up 2 units. And then over 3, half of 9 is 4 1/2. So I'll land right here on the x-axis, because if I'm at -4 1/2, that right there is a distance of 4 1/2, right? Over 3 up 4 1/2. So the reason this one was kind of like tricky was because even though your vertex was on a half bar, it ended up giving you a couple x-intercepts that were right on the x-axis. So actually, that was the last vertex. That was the last standard form problem on this practice. 4, 5, 6, and 7 are all practicing vertex form and multiplying binomials. So why don't you try the ones on the bottom? Maybe those will be okay. And maybe we can do one of the max and min problems from 214. I'll show you that one before. Does this go left and right? So it does not go left and right. Does it go up or down and not plus 1? Up? Yep. Yep. I'll put number 4 up. So this one does not go left or right. It goes up 1. Right? So I'm at 0, 1. So here's my vertex. There we go. So the axis of symmetry is going to be the vertical line through your vertex. So it's at x equals 0. So you write it like a vertical line. So then you would go over 1 down 2 and over 2 down 8. So I'd be way down. Oops, nope, I'd be here. I would actually be at -7, wouldn't I? Whoops. Because I'm at +1, so I have to get to -7. So that's steeper and that's upside down. If you notice something, this actually is telling you what your y-intercept is because there's a +1 here. And this you could also treat like standard form, -2x squared plus 0x plus 1. So if you wanted to treat that one like standard form, your b value is 0 and you can still use it as an equation. Now, it's this value. So this is a 1 right here. So it's the first step. It has not been done. You want me to check something for you? How are you doing? Well, that's okay. These are your transformation rules. Like, does that go left or right? Opposite what you think it should. So left or right? Left. The right, left 5. And what's the -3? Down 3. So it's -5, -3 is your vertex. Put a dot where -5 over -3 is. So the second one go up or down? Up, positive. Okay, your axis of symmetry is going to be this value. So x equals -5. Equation. And then you're going to put a dot where your vertex goes, where is -5, -3. So this way, -5. Right, and then will it open like down? Why? Well, that's this shift down 3. But the actual a value is sitting here at +1. So it's the parent function, which is the 1, 1, 2, 4, 3, 9. It's just from that point. This was the old stuff. So you feel like you're trying to do standard form on vertex form, which is okay. This just isn't standard form, so you can't do it. This is left 5. then down 3. So left 5, down 3. I think you were somehow doubling it to try to save your form. And then put a dot at -5, -3. Oh, they're right there. Okay, you just -5 first, though. -5 this way, and then -3 this way. The x is -5. Okay, so from there, that's your vertex. Let's change that to -5, -3. And then x equals -5. So that's vertical through there. So there's a 1 sitting in front of here. So you're going to do your parent ground off of that point going up. So those with like 1, 1. So over 1 up 1, over 2 up 4, and then over 3 up 9. That was your ground. You did this? Did you know you learned quadratics in math? Yeah. Okay. And then this one you just didn't log it. It should have been left 5 down 3. Because it's a negative 3. It's going to be down here and then it's going to be moving up. How are you doing on stuff? Yeah, good. Those are good. That's good. Because you missed Friday, you said? So. Okay, good. You feel like you know how to do this? Okay, don't forget when you double this, put your X. You did that right. Check this one again.
So what do I do?
Well, this you did right. What are you doing in your head? You got your x squared right. Yeah. So if you have positive 8 apples and you subtract 8 apples, there's 0 apples. There's no middle term. But then you still have to do last. Which one last? You first have your inner, but now what's last? -8 times.
Okay.
Because here you did -4 times -7 is 28. Okay, so I think I'll just take the last couple minutes and then you can relax or try maybe homework 2-5 would make me so happy. But I'll at least put these answers up. So this one should have been left 5. Don't forget your transformation rules from last week. Down 3. Left 5, down 3. X equals -5. So left 5, down 3. And then over 1, up 1, over 2, up 1, 2, 3, 4, because this is just the parent function. There's a 1 sitting here, just imaginary, like 1. So it's the parent function over 1, 2, 3. What am I at? -3, so I'd be at 6. 6, 6 on either side. So that axis of symmetry tells you that you could fold this graph in half at x equals -5. So we're doing lots of practice tomorrow on graphing quadratics, and this is all just multiplying using the FOIL or the box method. So I will maybe put these up for you to check in just a minute, but if you haven't tried a couple of these on your own first, why don't you check them before you just write all your answers down? Maybe I'll put up like the box so people doing the box can check. Oops. Zach, did you have this number on number 6B? Did you have -11x there? You did. Okay. I knew you had the 28. I forgot about that one. So don't just write them down. Try them first and then write them down. Or double check. Did you answer your question? I think that's right. Maybe someone who tried them all can make sure I didn't make any mental math errors when I was doing those fast, but I will leave those up there.